Hi, thank you all for being here. My name is Meiyan Xu, and today I'm presenting ABC Bank's AI-powered credit card approval system. With a specific focus on how we build this system to be responsible, fair, and explainable. I will not walking you through code or technical formulas. My goal is to give you, as senior leadership team, a clear understanding of what this system does, what the result tells us, where the challenges lie, and what needs to happen before going to production. So the problem is to the ABC Bank's credit card approval process is largely manual and rule-based. This creates three components issues: speed, um, customer expand near instant decision, and our current process cannot deliver that. Consistency, like manual review, introduce human variability that has nothing to do with creditworthiness, and the skills as our customer base grows, the cost of reviewing everything, application manual becomes unsustainable. So to solve this, we train a machine learning classifier on 9,109 historical credit card applications, each described by 16 features covering incomes, employment history, housing situation, family profile, and account turnover. So for data preparation, we remove the application ID, which carries no predictive information. We preserve the gender files separately, not as model input, but exclusively for fairness editing later. Categorical variables such as income type, education level, housing type, and occupation were encoded using binary income, age, and year employed were standardized, so large income values were not numerically dominate small-scale variables. The result was a clean process feature set of 33 variables ready for modeling. When selecting evaluation metrics, we have to confirm the classes imbalance handle in the dataset where a 86.8% of outcomes are Danos. A model that simply predicts Dano for every applicants will achieve 86.8% accuracy without learning anything meaningful. Accuracy is therefore a deeply misleading metric there, and we did not use it as our decision criterion. Instead, we select AUC/ROC as our primary metrics, which measures the model ability to rank credit-worthy application above risky ones across all possible decision scenarios. It's robust to class imbalance and is gold standard for binary credit risk models. We complement it with F1 scores, which balance precisions and recourse is specifically designed to handle imbalanced outcome along with precisions and recall individually. We test five classifier families, the largest regression, decision trees, random forest, XGBoost, and LightGBN. Each was evaluated using threefold satisfied cross-validation, ensuring every model was tested on balance. Representatives outside the cross-validation AUC-IOC scores was as follows. The largest regression achieved 0.5806. Decision tree is 0.5789. The random forest is 0.5820. The XGB bot is 0.5772, and the Lightband is 0.5659. So the random forest achieved the highest cross validation AUC and IUC at 0.5820. But for the final model training, we use LightGBN due to its architectural advantage for gradient boosting, which enables compatibility with the SHAP experiment framework we developed, and its training speed for future operational retraining. I want to direct with you about the final model set performance because intellectual honesty is central to responsible AI. On the hold-up test set of 2,425 applications, a large GPU model achieved an accuracy of 86.78%. However, the number is misleading. The number predict Daniel for every single applications, which means it similarly replicate the majority classes. As a consequence, precisions we call an F1 source are all zero for the purple class. The learning curves confirm the diagnosis. The training AUC reached 0.5699, but the validation AUC was only 0.5581, a gap of 0.2918, which our analysis correctly flagged as significant overfitting. The model has learned patterns in training data that do not generalize to new applications. The outcome is not failure of modeling approaches, it's a well understood consequence of observed class imbalance that was correct during training. The standard solution was well established, applying modes to synthetically oversample approach applicates in training set. Using class weighted losses function that penalize misses approvals more heavily than misses denials, or thresholds turn to move the decision boundary away from the default 50%. These are targeted proven intervention. The current result gives us a technological sound baseline and precise diagnosis of what needs to be addressed before development. So our result shows that the three fairness metrics produce a difference of exactly zero between male and female applications. The demographic practice difference is zero, equal opportunity difference is also zero, and transparency about why it's in this case because the currently model practice dynamic for all applications, approval rates and errors rates are mathematically identical across every groups. There are no disparity because there are no approvals. Once the class imbalance is corrected and the model begins producing positive predictions, we will rerun this analysis immediately. The framework is ready. We simply need the model to produce differential prediction before the metrics become meaningful. We also produce partial dependence plots for account length and age. The two most influential features this plot show visually how the predicted approval probability changes as age variables increase average across application. The account length curve shows a smooth moto- monotonically increased relationship. The longer the customer has been with the bank, the higher the approval probability. The age curve shows a similar pattern of increasing probability with maturity. Both relationships are intuitive and consistent with responsible credit risk practice. So let me bring this together. What is the project deliver is rigorously built foundation for AI-powered credit approval system, accompanies fairness, adapting infrastructure that is ready to operate the moment the model process. Differential decisions are thoroughly explainable AI framework using sharp that identified account length, age, total income, years employed, and number of family members as primary credit signals, and the precise, honest diagnosis of the model current limitation is zeroed classes imbalance causing over prediction of Daniels with a clear standard remindation steps influence. In closing, the work we have done is here is exactly what responsible AI developments look like. We build a model we measure its performance honestly, we identify its limitation precisely, and we put in place the fairness and explainability infrastructure that any production critic must have. We are not presenting the finished product today, we present the regulars foundation with a clear short path to producing readiness. That transparency and commitment to get hit right before deployment is what difference a responsible AI program from the use rush one? Thank you very much. I'm happy to take my question.